So in the previous activity, we saw that a force is acting from the center, and that force is allowed to move the stone in a circular path. So that force is called centripetal force. And the definition of centripetal force: the centripetal force is the force on an object on a circular path that keeps the object moving on the path. It always directed towards the center, and its magnitude is a constant. So up to here it is enough for the definition of centripetal force. And this centripetal force helps the moon to move around the earth. And same as planets also can revolve around the sun because of this centripetal force. So the centripetal force acting from the center. If moon is revolving around the earth, then earth is acting that force. And if planets is revolving around the sun, then force acting from the sun. Okay, so that doubt it is clarified now, how the moon and the planet that revolve around the earth or around the sun. And next doubt, if any object will falls from a certain height, that falls towards the earth only, not moving to upwards to moon or some other place. So that we can see that force is beyond that activity, it is a gravitational force. And before that, in the previous lesson we have learned force F equal to ma. Force F, that is equal to product of mass and acceleration. And if you will see the relation between this force, mass and acceleration, then acceleration is inversely proportional to the mass of the object. If mass is higher, then acceleration will be less. And force is directly proportional to the mass. Means if mass is higher, then force also will be more. That is why if you will compare when an apple falls from tree to the earth, that will fall, apple falls to the earth only, not the earth, it is not moving to the apple. If you will compare the mass of the apple and the earth, that will be more. Mass of the earth, that will be more than the apple. So the force acting from the earth, it is higher, that is why apple falls towards the earth. So everything we can say that everything in the universe that attract with a certain force, that force is called a gravitational force. We can see the definition. The force with which objects pull each other towards themselves is called a gravitational force. So everything in the universe that attract each other with a force, that force is called a gravitational force. And next we can see the universal law of gravitation. That is, every object in the universe attract every other object with a force, and which is proportional. That force is proportional. Proportional means directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It is the universal law of gravitation. Every object in the universe that attract each other, so that force is equal to or proportional to the product of their mass and inversely proportional to the square of the distance between them. That means if mass increase, then force also will be increased. But the distance between the object, if it is increased, then force will be decreased. That is inversely proportional. Then next we can see the equation of universal law of gravitation. So consider two objects, object A and B. Object A is a higher mass and object B is a less, compared with the A, less mass. So mass of object A, that is capital M, and mass of object B, that is small letter m. According to universal law of gravitation, force that is proportional, directly proportional to the product of their mass, that is m into m. And next, that is inversely proportional to the square of the distance between them, that is F proportional to 1 upon d square. D is the distance between the object. And by combining these two equations, F, that is proportional to product of their mass upon square of the distance between them. So this proportionality sign we can replace by capital G. Then F equal to G into product of the mass upon square of the distance between them. The value of the G, it is a gravitational constant. So the value of G, that is equal to 6.67 into 10 raised to minus 11 Newton meter square upon kilogram square. So up to page number 134. Above the example I have completed. Up to there you have to read, and after reading, if you have any doubt, you may ask.